So Informatica's big data journey began in 2012 with the introduction of Informatica Big Data Edition, where we were the first data integration platform to natively support or execute mappings on the Hadoop cluster by supporting MapReduce, having the support for HDFS, Hive, and HBase, and also profiling data natively on the Hadoop cluster. But we know, as everyone knows, that the Hadoop ecosystem was evolving, right? There were newer technologies being added to the ecosystem, as well as there were constraints with the current MapReduce framework. So everyone's familiar with the constraints of MapReduce, right? Where MapReduce managed both the processing and resource management of the Hadoop cluster. But with the development of Yarn, yet another resource negotiator, Yarn separated the processing engine and the resource management capabilities of MapReduce. What Yarn allowed us to do was, or allowed the ecosystem to do, was to allow multiple complex distributed applications running a multi-tenant platform, managing and monitoring their workloads, and implementing security controls and managing high availability features. Yarn also provided the capability of building custom application frameworks on top of Hadoop to support multiple processing paradigms, like we see today, Hive on Tez and Spark and so on. When Yarn was introduced to the ecosystem, Informatica Big Data Edition also supported this new resource capabilities, as well as the newer processing paradigms like Hive on Tez. So that was Informatica's own journey, right? All the way up to November when we released Informatica Big Data Management. What I wanted to do was, and I promise we'll get to the new features, but I wanted to talk a little about what our customers were facing during that time. Why big data projects were failing and how do you succeed with it? Because I think it's important. It ties back to how do you actually implement an entire big data project and how you can be successful in your big data implementation. So the biggest challenge that that I face, that an organization faced when we're doing implementations, is determining how to obtain value from big data. That's the first challenge. But the second one, and most importantly, is where do you start? Big data is like any other data, only more of it. It's more complex. It's in various forms. You have to sit back and think, like, how do I quickly integrate all of that data? Secondly, we know that big data is characterized by volume, variety, and velocity. And any enterprise that's in the process of considering a big data initiative has to address like the metadata management, metadata management, so that you can exploit the business value hidden in the new data sources by discovering, relationships between these data sets. And then most of the data, in context of big data, comes outside of the enterprise. So you don't know its structure, you don't know its origin. So the likelihood of the quality of that data is going to be very high, very poor. So you have to implement a data quality, data governance solution as well. And then finally, we look at data security. How do you secure a cluster with so much more data? How do you put in policies so you have the right people accessing the right data sets? Hadoop is being used as a data integration platform, which is great, but that doesn't eliminate the practice of data management as a core, right? So if I take a step back, everyone's done a data warehousing implementation, and everyone's implemented a data management principles, right? So big data shouldn't be any different, right? Yes, it is just data. So why not correctly implement data management principles to your big data project? So how do you go about being successful in this implementation, right? So like I said, you have to apply data management principles to the big data ecosystem, right? So you have to have a solution that is a single and comprehensive and an integrated platform for end-to-end big data management, where you can quickly integrate the data from any type of source, unstructured, structured, transform this data and load it to your Hadoop or NoSQL platform. You have to be able to provide good governance and also good quality, because you want to ensure that the data scientists who are looking at the data have good quality data to make the right decisions and to make the right or build the right models. And then finally, again, how do you secure that data? Make sure that you secure the cluster. Make sure you have the policies in place for the right people to access the right data sets. All right, so one more slide, and then definitely we'll talk about the new features in big data management. But in this slide, I wanted to give an overview of what a conceptual big data process flow looks like, going from source, what the big data management process is like once the data is on the Hadoop cluster, and then how it's made available for the business analysts, for the data scientists, to look at the data. Most customers, most organizations begin their first step of the journey by offloading data to the Hadoop cluster. Typically, ELT data, ELT processing, or offloading infrequently used data to the Hadoop cluster. A use case primarily known as data warehousing optimization. In the next step, then you want to ingest data directly from the source system, whether it's transactional or multi-structured data directly onto the Hadoop platform, further reducing impact on the warehouse itself. And then you want to replicate the changes, right? Any schema changes can be replicated directly to the Hadoop cluster, offloading processing from the OLTP or mainframes and operational data stores. And then you have data that's generated by machines, sensor data, right? Web logs, application logs, can be collected in real time and streamed directly onto the Hadoop cluster. So once the data is loaded onto Hadoop, analysts can discover the data, profile the data, understand what its structure, what its context is, and then add requirements for enterprise accountability, right? More on the governance side. Is it compliant with the corporate and government regulations, or does it even meet does it meet the business SLAs? Then you can prepare the data, right? Make sure that the data that you have, is parsed, is prepared, and ready for analysis. You can also mask the data. Make sure that the sensitive data is masked so that any analyst, anyone accessing data, does not see customer PII information. And then you finally move the curated data to the data warehouse and have it available to have it available for BI reports, or you can have BI reports directly look at the curated data itself. So this is just very high level process of what it takes to implement a big data strategy. So some of the customers will implement all of these, some of them won't. They will only use a subset of these, but the core remains the same, right? You still have to have a big data management process to make sure that you can quickly integrate the data, make sure you can govern, make sure you can provide quality data, and then make sure you secure the data. So you look at these 9 steps, and like I said, these would be the 9 steps that you would probably implement in your big data process flow. This is not an easy step to implement, right? So what are the challenges that you would face in this implementation, and how does big data management go about solving it with the new features? So up to this point, I talked about Informatica's big data journey, right? How we went from or how we succeeded with Informatica Big Data Edition. And then I talked about our customer implementations, their challenges, and a very conceptual big data process flow. So as I talk about the new features here, we heard a lot from our customers about their challenges, about their pain points, about implementing a big data strategy as a whole. If you take a step back and you look at the broader Hadoop ecosystem, you realize that there is no one solution for complex batch processing. There are huge gaps with respect to the current big data processing engines and programming frameworks, right? These frameworks such as MapReduce, Hive on Tez, even to some extent Spark, are good for certain use cases, but they heeded that core functional and performance requirements for big data integration. Secondly, a big data journey should be lean and agile, right? Focusing on reusability, focusing on automation and optimization of these data flows. one of the common requests that we got was the ability to make the data flows more flexible with respect to development. What this means is that a customer who's going down this journey of implementing a big data project, most probably has a existing EDW where they have thousands and tens of thousands of mappings, but these mappings are tightly bound to schemas. So you know that if there's any changes to that metadata, right, if there's any changes to the object, whether it's a data type, whether it's a column change, it could impact hundreds of thousands, thousands of transformations and mappings, posing a bottleneck at each stage of the big data process flow process. And then finally, you realize that there isn't a solution where you could search and discover relevant data sets, right? With data that's flowing in and out of the Hadoop platform, to the enterprise warehouse. How do I look at how can I search for data assets? How do I understand what data that I have on the platform, right? How do I discover these relationships just so that I can easily find these data sets for my implementation? So we'll begin by addressing the functional and performance gaps of the processing engines on the Hadoop cluster. So as I mentioned earlier, Yarn provided the capability to build out custom application frameworks on top of Hadoop to support multiple processing models. That's where you see Hive on MapReduce, Hive on Tez, and then you see Spark. And then there's more frameworks on top of that. So what we did with Informatica Big Data Management is that we combined the best of open source, which is Yarn, and 23 years of data management experience to build out Informatica Blaze. So what is Blaze? Look at Blaze as a cluster-aware data integration engine for Hadoop. Blaze was built using in-memory algorithms, all built in C++, for big data batch processing. Blaze is definitely integrated with Yarn, so it's very scalable. It's a very fast, very high-performance distributed processing engine for Hadoop. So, I can feel people just glued on the screen and asking this question, does Blaze replace the other big data processing engine frameworks? Does it replace MapReduce? Does it replace Tez? Does it replace Spark? And the answer is no. What Blaze does is that it actually complements the capabilities of the other, other processing engines, because, there is no one solution to solve all of the big data batch processing use cases. So what we did to overcome the functional gaps of the other processing engines was to expose our transformation libraries that we've built over 23 years to the Hadoop ecosystem, to a distributed processing platform through our engine, Informatica Blaze. What that allowed us to do was to expose a lot of our functionality, not just the core functionality of joiner transformations, aggregate, and lookup, but we are also able to expose our complex transformations, right? Complex data integration transformations, the complex data quality, data profiling, as well as the data masking transformations through the Blaze engines, making it much more easier for you to implement complex ETL processing for a Hadoop ecosystem, for a distributed processing platform. Now, in terms of performance, what we did was, like I stated, right? We took Blaze, made it an in-memory processing engine, built it purely on C++. And in the next few slides, especially in the Blaze lifecycle slide that I'll talk through, I'll explain how we actually use in-memory processing for our Blaze engine. So, I can see the next question, right? I've explained what Blaze is. And so the thought's probably running through your mind, like, okay, look, if I'm going to execute a mapping on the Hadoop cluster, it's automatically going to default to Blaze engine, right? So how do you say it complements the other existing processing frameworks? So what we did with Informatica Big Data Management is release the Smart Executor. Another key innovation for the Hadoop ecosystem. What the Smart Executor does is that it dynamically, automatically, and intelligently selects which is the best execution engine to process the data, based on, the workload type, based on the mapping, based on your infrastructure configuration. I'll walk you through the mapping during the demo, but let's say I have a mapping and I want to execute on the Hadoop cluster. What the Smart Executor will do is optimize that mapping, and based on my cluster configuration, determine which is the best execution method to run it on, right? So it could pick, out of the supported frameworks, MapReduce, Hive on Tez, or even the Blaze engine itself, the Smart Executor could pick out Hive on Tez being the faster engine, right? So it is optimized and it's built to intelligently pick out which is the best execution engine to run on. If you take a step back and really think about this for a second, you will see that with the release of Informatica Big Data Management, specifically the Smart Executor, it's a polyglot engine, if you will. A polyglot meaning that it has the ability to understand multiple languages. On the other hand, polyglot implies that not one technology, whether it's storage, whether it's language, whether it's the processing framework, will solve all the big data integration use cases. Like I stated, right, a polyglot engine, just like the Smart Executor, will be able to figure out which is the best processing engine to execute your data workload based on that given processing task. Okay, so how do you go about using the Blaze execution engine, and how do you go about configuring your mapping to use the Smart Executor, right? So in the next three slides, I'm going to talk to you about the design time aspect, what it takes to configure a mapping to use the Smart Executor and the Blaze engine at design time, and then as well as I'll talk about the Blaze lifecycle. So here I have a mapping, right, that I want to execute on the Hadoop cluster, and I would consider this a medium complexity mapping. So how do I go about configuring it to use the Blaze engine or even using the Smart Executor? So all I need to do is I need to assign a connection object that tells the Smart Executor my cluster configuration, and the Smart Executor will go ahead and do the rest, meaning it'll go ahead and optimize the mapping and figure out which is the best execution engine to use. And I'll show you this here in the demo in a second. I've stated that the Smart Executor is like a polyglot engine, understanding multiple languages, but it goes one step further, and it offers a zero-click execution across big data engines, right? Like I said, right, the Smart Executor is designed to automatically, intelligently figure out which is the best execution engine to use based on my cluster configuration or your cluster configuration, or any future engines that the Smart Executor would integrate with, such as Spark or Flink. Now, if you really take a step back and think about this is a true layer of abstraction between design time and runtime, because this future-proofs your development against any newer processing engines that may come up. So there will be no need for me to take this mapping and convert it, translate it, transform it to use that newer processing engine. What the Smart Executor will do at the time it will be integrated with the newer processing engine is it will automatically convert this mapping and submit it to that newer processing paradigm. So I want to take 1 or 2 minutes and talk about the Blaze execution plan, because the Blaze execution plan tells you how the mapping is going to be executed on the cluster. It is computed dynamically for the selected processing engine that the Smart Executor decides to use. So when you view the the execution plan, Informatica will first display the plan as a high-level workflow. And when you drill down through the workflow, you will see that there have these grid mapping tasks or mapping grid tasks. And what these are actually Informatica mappings, big data mappings, that the Blaze engine will compile, will optimize, and distribute across the cluster for processing. These DEF links, these are data exchange framework links that tells Blaze how to, exchange data between the nodes, when it processes data. And I'll explain this in the life cycle in the next slide. So here, if I look at the, submapping 7 task, you will see this as a grid segment. And if you expand the grid segment, you will see it as a mapping that will be run in a distributed manner, or that will be executed in a distributed manner on the Hadoop cluster using the Blaze engine. All right, so let me quickly walk through the Blaze lifecycle, and then we can go into the demo. I've talked about how to configure a mapping at design time to use the Smart Executor and the Blaze engine. I've also talked about the execution plan. Now let's take a look and see, behind the scenes, what happens when the mapping is executed on the Hadoop cluster. So when a mapping is executed on Hadoop, the resource manager, Yarn in this case, assumes the responsibility to negotiate resources. The grid manager is like the application master, right? It interacts with the resource manager by acquiring all the resources, deals with the fault tolerance, and ensures that the Blaze services are started and are healthy. The orchestrator works with the grid manager to request resources. It schedules tasks on nodes that have resources available. Then you have the DTM container that is responsible of executing the mapping on the node with the help of the data exchange framework daemon. This is the most important component of the Blaze framework, the DEF, the data exchange framework, because it's responsible for storing the intermediate results of the tasks and exchange data between the nodes. It is an optimized fault-tolerant framework during the shuffle phase. So if you're familiar with the map shuffle reduce phase, you'll know that the shuffle phase is pretty common in big data integration processing. So what Blaze does is that using the DEF daemons, it shuffles data in memory between nodes, and it also has the capability of determining whether to use it in memory or disk for certain workloads. Now, once the process is once the process is complete, the DTM container then reports the execution monitoring information back to the orchestrator. The orchestrator then consolidates the execution stats reported by each of the DTM containers and writes this information to the storage, which is the application's time server, and then it makes these stats available for viewing through the Blaze job monitor. Now that I've described Blaze, let's take a look at a demo. In this scenario, I created a mapping using the TPC DS benchmark queries. I used query 15, which reports the total catalog sales for customers in a selected geographical region, or customers who made large purchases for a given quarter. Okay, so I logged onto the developer tool. So this is a tool that I'll use to create artifacts such as mappings and profiles that will run on the Hadoop cluster. So here I have the mapping that I talked about, right? The category sales mapping. And I need to configure this for running it at the Blaze engine. So what I did is that I predefined a connection object before this demo. And I've already went ahead and created all the configurations and set up the configurations that I needed. So here I've specified the Yarn resource manager, the default FS URI. I've configured for map reduce, and I've set up my Blaze engine properties as well. So I go back to the mapping canvas, and I'm going to select runtime object. Here I have two environments. One is the validation environment, one's the execution environment. With the validation environment, I check Hadoop and Blaze. So what this will do is that the Smart Executor will first validate this mapping against the best engine that it's going to run on to ensure that it's valid before it runs on the cluster. And then under the execution environment, obviously I'm going to pick Hadoop because that's where my cluster is. And I'm going to select the connection object that I had just created to run on the cluster. Okay, then I have the execution plan. So as this comes up, let me do this. Let me go back and run this mapping because I don't have a lot of time during this presentation. I'm going to run this mapping in the background and let this execute. But I'm going to open up the execution plan as I talked about. Right, so this is the high-level workflow, and if I look at the subtasks related to it, these are the subtasks that the smart executor creates based on the engine that it's going to use. In this case, Blaze, to execute the mapping. So if I look at the mapping, so these are the sub-mappings that will run on the cluster in a distributed manner. So if I go back one. These are the links that I mentioned, the data exchange framework links that tell the Blaze engine, how to exchange data between these tasks and between nodes as it's running on the cluster. And like I said, this entire process is running in memory on the Hadoop cluster. Okay, I'm going to log on to my UI, and you can see that this is the UI where I can monitor the state of the job that's running on the cluster. So this is the mapping that's running right now. I already pre-ran a mapping earlier just in case I didn't get the time to do so. So it's the same mapping that I ran. So if I drill down, you'll see the sub-mappings that are associated with the execution plan that I just showed you. So here you can see, if I go back to the top, we have the Blaze execution, we've got summary stats, and we've got detailed stats. But if I look at one level down at the grid master task, and I see this monitoring URL, if I click on that monitoring URL, this gives me the status of those grid tasks that are running on the cluster. And then I can drill down further, and if I need to debug on what that particular job is doing, I can do so with the Blaze monitor as well. So if I look at the mapping properties and I look at the summary stats, you can see that there's quite a bit of records that it read. So I'm going to increase here. So here I've got about 250, 500, and 14 million. So I'm reading close to about maybe 15 and a half million records. And what you can take away from this is that this mapping ran in about 1:14. It read about 15 million records. It transformed the data and outputted the data onto HDFS. Alright, so this concludes the Blaze demo, and we'll go back to the presentation. Alright, so you've seen the Blaze demo. You've seen how it's configured, how it's run on a Hadoop cluster using the smart executor. Now, I know there's one lingering question out there, and it's about performance, because throughout my presentation I said that Blaze is an in-memory processing engine, and we know that Spark does in-memory processing as well. So how does this compare with performance? Now, I didn't have time to do this in the demo because I only have an hour. So what I did is I asked our engineers, I took the mapping that I created and asked our engineers to convert it to Scala code and see if they can give me some performance numbers. So what they did is they took the mapping, converted to Scala code, and converted and kind of compared it to Hive on MapReduce and Spark. And what they did is that they compared over three data sets, right? They compared over 300 GB data sets, 1.5 terabytes, and then 3 terabytes worth of data. And these are the results that they came back and then presented back to me. So when you look at the graph, you can see that, comparing just Blaze and Hive on MapReduce, you can see that Blaze is much faster, anywhere between 15 to 20% faster than Hive on MapReduce. Then you look at Spark, and then you can see that, Blaze is much faster than Spark by at least 3 to 5%. So now you sit back and you say to yourself, well, what makes Blaze so unique that it is faster than Spark in terms of performance? So why is Blaze so fast? What makes it so unique? With its multi-tenant architecture, Blaze allows you to run concurrent jobs, which means that you can run multiple jobs served by one single Blaze instance. So this provides better resource utilization and sharing amongst these jobs. So even if you have like 100 mappings or 1,000 mappings that you're executing, Blaze will only start one yarn application. As I stated earlier, Informatica Blaze was written in C++ code, which provides better memory management compared to a Java-written framework. Blaze also uses the data exchange framework, right? A process for the shuffle phase, which is an in-memory built framework that shuffles data amongst the nodes without the loss of recovery, which is a very key capability in big data processing for big data processing engines. And then we have the smart executor, which provides this layer of abstraction between design time and runtime, where the smart executor decides which is the best execution engine, processing engine to use for the particular workload that you're executing on your Hadoop cluster. Then there's the functionality, right? So with Blaze, as Blaze runs as a native engine on top of Yarn, it has the flexibility to support all of Informatica's data integration transformations that include the core data transformations to the advanced data integration transformations, data profiling, data quality, data masking transformations. And then finally, from a logging and monitoring perspective, Blaze, as you saw, has a console that runs on top of the application timeline server, which can help your operations team to monitor and debug mapping executions on the Hadoop cluster using the Blaze engine.